Okay, this video is going to be about exponentials and logarithms. So the last video was about, functions and their inverses. So I'm trying out a new microphone here. My other one was a little, okay, we'll see how it works. So the general exponential function is going to be y equals a to the x, where a is a real number, and typically we want a to be greater than 0. Okay, and so if I were to plot that, then I would get a function. If a is bigger than 1, it would go up like that. In fact, what is this point right here going to be? That's a to the 0 power, and we know that the a to the 0 power is going to be equal to 1, so the graph is going to go through there. Yeah, so and over here, you can see that this is going to be a to a negative number. So for example, a to the minus 10 power, what's that going to be? That's going to be 1 over a to the 10th power, so that's going to be very small. And so that's why as x goes to minus infinity, the graph is going to 0 on this side. Then of course on this side, it's blowing up. And that's true when a is bigger than 1. Okay. What happens if a is between 0 and 1? So for example, a equals 1/2. Then the graph is actually flipped. And the reason is because 1/2 to the x, you could rewrite that as 2 to the minus x power. And then you could think of that as being f of minus x, where f of x is a to the x, right? And so it's taking this graph and it's reflecting that across the y-axis. And so this would be the graph of something like 1/2 to the x power, where you're blowing up as x goes to minus infinity, and you're going to 0 as x goes to positive infinity. Good. And so we see here in both cases the domain is the real numbers, and the range is the set of positive reals. And notice that excludes the point 0, right? Excludes 0. Good. All right. Now, one of the most important exponential functions is the e function, right? E to the x, where, where e is approximately equal to 2.71828. Okay, and so you could just remember that it's a constant and it's a little less than 3. You can just think of it that way. It pops up in a lot of different places, and using techniques of calculus we can actually define e. So for right now we're just assuming that we know what e is, and e is a constant that pops up like that. Okay, now the logarithm is defined to be the inverse of the exponential. And so let's see how that's going to be defined. So for example, if we take y equals a to the x, domain is going to be the reals, range is going to be the positive reals, then the inverse would be a to the y equals x, right? And so if I were to solve that, I get, by taking the log of both sides, we're going to talk about that in just a second, we get log base a of x. So this function is the inverse of this function, and so the domain would have to be the positive reals, and the range is all reals. And in fact, let's go ahead and graph the two things as well. So maybe I'll draw these in different colors. Maybe the original function in purple. So if I have a to the x, it's going to look something like this. And then let's draw the line y equals x. And so what would the inverse be? I'll draw that in green. Okay, so this is log base a of x, and this is a to the, oops, sorry about that, a to the x. Good. All right, so notice that the log function has a horizontal asymptote, or sorry, the exponential function has the horizontal asymptote, and so the logarithm has a vertical asymptote. That's what I'm trying to say. If you saw me in the last video, I seem to be getting my horizontal and vertical mixed up. Sorry about that. Okay, some points on the graph of a to the x, right, are if I plug in 0 for x, I get 1. If I plug in 1, I get a. And if I plug in -1, I get 1 over a. So what are some logarithm values? Well, we just reverse those, right? So what's the log of 1? It's equal to 0. What's the log of a? It's equal to 1. And what's the log of 1 over a? It's -1. So we could double check that. But that makes a good note here. Log base a of 1 is equal to 0. Log base a of a is equal to 1. And notice that log base a of 0 is not defined. Good. All right. So let's take a look at some properties of the exponential, and then we'll look at properties of the log. So properties of the exponential. If I have a to the x plus y, that's a to the x times a to the y. That's another way to write it. Or a to the x minus y is a to the x times a to the minus y. And a to the minus x, right, is 1 over a to the x. And so this becomes a to the x, let's put an equal sign there, divided by a to the y. Okay. Sorry about the mess. A to the x to the y is a to the x times y. Let's see, anything else? AB to the x is a to the x, b to the x. Okay? Furthermore, because the exponential and the log are inverses of each other, inverse relations, we have that e to the natural log of x. Oh, I should define the natural log of x. Sorry about that. I did not do that up here. Let me do that right now. We know what the natural log is. The natural log is log base e of x. Okay, and that's usually denoted as ln of x, which reverses the natural log words for some reason. Okay. Now, oops, sorry about that. So we have a to the x equals y, right? So what happens if I replace x by log base a of x? Well, these are inverses of each other, and so this just turns out to be x. And so similarly, if I take e to the x, then e to the natural log of x is just going to be x, so that undoes the other version there. Similarly, log base a of a to the x is equal to x, or another way to say that is that the natural log of e to the x is x. Good. Now, just a quick note about some of the properties of logs, and then we'll work with them a little bit. Starting to run low on time. I may have to do my examples later. Natural log of AB is natural log of A plus natural log of B. Notice that natural log of A plus B cannot be simplified. Okay, so then what would the natural log of 1 over a be? Well, that's the natural log of 1 minus the natural log of a. And natural log of 1 is 0, so that's just minus natural log of a. Okay, natural log of a over b in a similar way. And then natural log of a to the b. This is an important one. B natural log a. Good. Finally, if I take log base a of b, another way to write that, if I were to use a calculator, is to take natural log of b divided by natural log of a. Okay, I've run out of time for this video, so I'm going to summarize. I'm going to keep this as a summary for the next one, and then we'll do some examples.